Hello, my name is Marcos Tileria, and I'll be presenting this paper, Watch Over Your TV, a security and privacy analysis of the Android TV ecosystem. This is joint work with Jorge Blasco from Royal Holloway. I bet that most of you have one of these devices in your home, either a built-in smart TV or an OTT device like an Amazon Fire Stick. And if you are from the US, the chances that you are reachable by connected TV advertisers goes up to 90%. The connected TV landscape has experienced an explosive growth in the last couple of years. The popularity of streaming services, affordable prices, and enhanced user experience has contributed to the wide adoption of smart TVs. Smart TVs rely on channel or apps to deliver streaming content over the internet. These allow users to interact with the app, unlike traditional televisions where the experience was mostly static. Now, there are two important works that have recently analyzed smart TV platforms in terms of security and privacy. These works mainly focus on Roku and Fire TV, while in this work, we analyze the Android TV platform. So why is that? Now, Android TV is highly compatible with other Android platforms, in particular with the Home Assistant. And Google also claims that there are 110 million active smart TV devices and more than 10,000 TV apps in the Play Store. The Android TV platform has experienced an 81% increase of viewing per time since 2020 and is available across many brands. Now, TV apps are similar to mobile apps in the sense that both are based on Android. So they share the same structure and developers use the same tools to build the apps. But TV apps also present unique characteristics, such as the data they handle, the library they use. One example is the leanback library, and the user experience. Now, TV apps must declare a TV activity in the manifest and other custom configurations. So then Google uses this information to enable one app in the Android TV Play Store. There are also different types of TV apps, as we can see in the screen. On the top, we can see popular streaming apps, but lower, we also see many general purpose apps. And in particular, fitness and education apps have tripled in the last 2 years in the Play Store. So this is the first important difference that we want to highlight in Android TV. When an user wants to install one app, the information is almost non-existent. They only have available a short description, and that's it. And considering that TV apps have similar capabilities to mobile apps, we expect similar threats. However, there is no way to read permissions, user reviews, last update, or even the privacy policy in Android TV. And this is a big difference with the Android mobile platform. And with this in mind, we decided to do a systematic analysis of this ecosystem. To better understand these threats in Android TV and to understand the difference with the mobile platform, we did a systematic analysis of TV apps that include information flows, inter-device communication, external dependencies, and bad development practices. So first, we collected around 5,000 TV apps from the Play Store and APK Mirror, and we analyzed the repository metadata. We also use static analysis to analyze permissions, libraries, information flows, and more. All of this complemented by reverse engineering and manual analysis of selected cases. We also ran a traffic analysis experiment using a small subset of 65 popular streaming apps. In this experiment, we execute the TV and mobile version of the apps, and we analyze the decrypted network traces. So a couple of things to mention. Android TV is more limited than Android for smartphones. For instance, it's not possible to install custom certificates. So we relied on instrumentation to force the apps to use our man-in-the-middle certificate. The instrumentation also removes certificate pinning checks and write a couple of lines to log potential identifiers and sensitive data before recompiling the app. Regarding the execution, we log in on each app before exploring to get better results. The exploration time is around 15 minutes. And after that, we search for any leak identifier or sensitive data in the network traces. So time for the results now. Due to time limitation, it is not possible to show all our findings here. So I encourage the audience to read the paper for a better understanding of the problem we found in Android TV. Our static analysis results show potential sensitive data exfiltration in more than 70% of the apps. If we look only at TV streaming apps, this number goes up to 83%. Most sources are reading static identifiers. In contrast, sources from Google Ads identifier library, which provide resettable identifiers, are almost non-existent. The results also show many streaming libraries potentially collecting sensitive data. Some libraries even mention in their website their invasive behavior, such as the collection of installed applications and constantly scanning networks. One example is Bisbee, that claims the possession of a graph of available devices across millions of homes in which they can distinguish between private homes and public places. These results show potential invasive behavior. Now the question is, can we confirm this finding with our traffic analysis experiment? And the answer to a large extent is yes. We can see in this slide the figure of contacted domains and traffic analysis results. So we first classify traffic to first-party content delivery networks and trackers. And it is already clear from the plot that traffic to trackers are quite prevalent. With this classification in mind, we consider that a data leak represents a privacy issue if the destination is a tracker. And we were able to find that trackers are collecting most types of sensitive data, from static identifiers to viewing history. In this capture, we can see the title of a program being leaked to a well-known tracker. And not only the title, other metadata such as the description and the category are leaked alongside the title. The results of static analysis and dynamic analysis complement each other. For instance, for detecting media metadata like viewing history, the dynamic analysis was more effective. This is probably because the developers are using libraries to manage streaming content, and it's very difficult to have a complete list of sources for static analysis. But for other types of sensitive data like location, the static analysis gave better results. In general, static analysis results gave us a guide on what apps should we explore and what type of data should we look in the traces. Our results show that multiple cases of trackers collecting static identifiers and sensitive data. We consider that this is problematic because the user has no option to read the privacy policy in Android TV before installing an app. This clearly shows that there is a lot to do regarding user privacy in Android TV. We note difference when analyzing the mobile and TV version of popular apps. For instance, mobile apps receive more frequent updates. Looking at the information flows, we found different sources. And when analyzing permissions and libraries, there are also many differences. And most notably, TV apps contact different domains than mobile apps, from trackers to content delivery networks. This shows that even though both versions are Android apps, their behavior and configuration are quite different. We also note a significant degradation of user rating for the TV version, as seen in this table. The Android TV documentation mentioned that it's very easy to port mobile apps to Android TV. However, it is clear that it's not that easy to publish good quality apps. During our different evaluations, we found many cases of permission inconsistencies, non-existent functionalities, and a lot of complaint in the Play Store about user experience and user interface as result of buggy apps. This shows that developers are not making the effort to maintain good quality apps, and Google is failing to provide a proper guidance. To conclude, Trackers are collecting all sorts of data that goes from viewing history to static identifiers. And this not only means the ability to track behavior across apps, but also means that the new Google policy of restricting advertising IDs will have limited impact in the Android TV ecosystem. Also, porting mobile apps to Android TV generates problems that are not being considered properly, neither by the developers nor by Google. As recommendation to improve the ecosystem, we suggest a more privacy-aware user interface that allows Android TV users to review permissions and privacy policy before installing apps, and better guidelines for TV apps developers to port mobile apps to Android TV. Thank you very much. You can find the link of the repository in the slide, and now I'm open to questions.